Hello everybody, I welcome you all to NCAS Geology class. In my previous classes, I have discussed about some of the classes of crystals, particularly the lower classes, triclinic, monoclinic, orthorhombic and tetragonal systems I have discussed, and there are two other systems which are left. They are hexagonal system and cubic system. Let me discuss the various classes of the hexagonal system. So in hexagonal system, the crystals they present 4 crystallographic axes, out of which 3 are horizontal and equal, which are designated as A1, A2, A3, and they make 120-degree angle with each other, particularly from their positive end. A2 is horizontal, and from that we have 128 degree, that is given by another axis, another axis. This is A2 120 degree like this. This is 120 degree. This is A2. This is A1 positive end. Then 128 degree. Another. This is A3 positive end. This is A3 negative end. This is A1 negative end. This is A2 negative end. So negative end. So these are the 3 horizontal axes, and we have one vertical axis C, which may be shorter or longer compared to the horizontal axis, and the angle between A1, A2, A3 is 120 degree, and A with C, that is always 90 degree. So this is the axial relationship in case of hexagonal system, and the common graphite symbol is HKIL, where H plus K plus I is equal to 0, and H is generally greater than K. And the Hermann-Marguin notation, so the first number in case of the classes of hexagonal system, the first number refers to the principal axis of symmetry, which is coincident with the C axis. The second symbol refers to symmetry elements parallel to crystal axis, that is A1, A2, A3. And the third symbol, if it is present, it refers to the elements perpendicular to the crystal axis A1, A2 and A3. So what are the different classes of hexagonal system? There are 12 classes: 6 by M, 2 by M, 2 by M. It is the beryl type, showing highest symmetry in hexagonal system. Then 6 bar M2, 622, 6 mm, 6 by M, 6 bar is equal to 3 by M, 3 bar, 3 bar 2 by M, 3 2, 3 M. So these are the 12 classes, and let us discuss these classes with respect to their symmetry elements and their stereographic diagram. So the 6 by M, 6 by M, 2 by M, 2 by M is the normal class, or it is the holoidal class of hexagonal system. The normal class, it is known as dihexagonal dipyramidal class, and commonly this notation is represented by 6 by MMM. Symmetry elements, one axis of 6 fold, that is the vertical C axis, 6 axis of 2 fold, 3 are axial and 3 are midway between the horizontal axis. 7 mirror planes, one horizontal, the other 6 are vertical. 3 planes, they are perpendicular to the symmetry axis. But these mirror planes, all except horizontal plane, other 6 planes, these are vertical and they are perpendicular to symmetry axis. And a center of symmetry is present, forms channel, pinnacles, prisms, pyramids and dipyramids. And this is how the axis of two-fold symmetry that has been shown. And this is axis of six-fold symmetry. C axis is the axis of six-fold symmetry. This axis of six-fold symmetry. And the horizontal axis, along the 3 axes we have 3 axis of two-fold, and bisecting these axes we have the another 3 axes of two-fold. So like this we have 7 axes of symmetry. We have the 7 planes. One is the horizontal plane, the other 6 along the axis and perpendicular to the axis. We have the, or bisecting the 2 axes we have another, with the planes along axis 3, and in between the axis there are other 3. So like this there are 6 planes, 6 vertical planes. And if we talk about this normal class, the minerals are beryl common, molybdenite, pyrrhotite, nicolite, these are the common minerals in hexagonal system. And we have highest 24 faces, dihexagonal, dipyramidal form. In this form has been represented here in this stereo diagram. One axis of 6-fold, perpendicular to it is the mirror plane, the horizontal mirror plane, as it is possessing horizontal mirror plane, so this plane is solid. And we have the vertical planes along the axis, these are the along the axis, Originally this is A1, this is A2, this is A3. Between A and A2, this one, between A1, A2, this is another one, and this is between A1 and A3, this is another one. So 6 planes, and for each face there is another face on the bottom, which is the mirror image of the other. That's why we have 12 upper faces, 12 faces on the lower part. So one is the mirror image of the other. That's why we have the circle, we have the bull-like structure. These solid dots, they represent upper faces, the open dots, they represent the bottom faces. So this is the figure, this is the stereo diagram, this is solid, these are the axis of two-fold symmetry, these are the axis of two-fold symmetry, these are the axis of two-fold, this is here it has been, here it is two-fold. So this is about 6 by m, 2 by m, 2 by m dihexagonal dipyramidal class. Next we have 6 bar m2, which is called as, this is 3 by m. So trigonal dipyramid m, so ditrigonal dipyramidal class. one axis of 6-fold rotor inversion axis, that is C axis. C axis of 2-fold lie in the vertical mirror planes. Three axis of 2-fold, three mirror planes this is 3 axis of 2-fold axis of symmetry lie in the vertical mirror planes. Three mirror planes are, one is vertical that intersects C axis and perpendicular to 3 A1, A2, A3 axis. One horizontal mirror plane perpendicular to 6 bar, because 6 bar is equivalent to 3 by m. So here one mirror plane, here there are three mirror planes. So total four mirror planes. Three axis of 2-fold. Three axis of 2-fold, four mirror planes, and one axis of 6-fold rotor inversion axis. This is the symmetry element, and this is the ditrigonal dipyramidal class, because 6 bar is equal to 3 by m. So this is 3 by m means trigonal dipyramid. With m and 2, it becomes ditrigonal dipyramidal class. So the forms are ditrigonal dipyramid, pinacoid, trigonal prisms, hexagonal prisms, trigonal dipyramids, hexagonal dipyramids. Common mineral is benitoid. This is benitoid, common mineral. And we have one axis of 6-fold rotor inversion. This is the 3 by m. This is being represented like this. 6 bar axis, and we have 6 bar m2, 6 bar m2, that is equivalent to 3 by m2. So we have this 6 bar is here, this m and this m. This m is this one. This is the axis perpendicular to the 6-fold rotor inversion axis. This plane is perpendicular to 6-fold rotor inversion axis. These are the three mirror planes, which are three mirror planes and three axes of 2-fold symmetry. So these are the three axes of 2-fold symmetry containing the mirror planes. These are the three axes of 2-fold symmetry. These are containing the mirror planes. So we have three mirror planes vertical which intersect C axis and perpendicular to the three crystallographic axes. This we will have to remember. They are perpendicular to three crystallographic axes. This is A2 axis. Perpendicular to it is the mirror plane. This is the mirror plane. Then this is A3 axis. Perpendicular to it is this is the mirror plane. Similarly, this is A3 axis. Then perpendicular to the mirror plane. So you have three mirror planes, three vertical mirror planes, and one horizontal mirror plane. So total four mirror planes. This point we have to remember here. Three mirror planes, vertical that intersect the C axis and perpendicular to the three crystallographic axes. Then 6 mm. It is one axis of 6-fold, three mirror planes axial, three mirror planes diagonal. So it is dihexagonal pyramidal class. it has no center of symmetry because biM is not there, and common form HKIL. Minerals are woodsite, greenockite, ginsite, and ginsite it shows a Padian base. This is the Padian base. On it hexagonal prism terminated by hexagonal pyramids are there. So 6 mm. So this is the axis of 6 pole symmetry. One axis of 6 pole symmetry. One axis of 6 pole. Then M represents 3 mirror planes, and these 3 mirror planes 6 mm, these are the 3 mirror planes. There are 6 mirror planes here, 6 mirror planes and no center of symmetry. So it is not having horizontal plane of symmetry, that's why it is dotted. Then these are the 3 mirror planes. Besides these are the 3 mirror planes. So there will be 6 mirror planes. So these are the 6 mirror planes. These are the 6 mirror planes possible in 6 mm. If you look at the stereo diagram of 6 mm, this is 6 mm. So these are the 6 mirror planes. A horizontal plane of symmetry is lacking. So that has been shown here. So here 3 axial and 3 diagonal. So 3 axial and 3 diagonal bisecting the axis or perpendicular to the crystallography axis. Thus we have 6 mirror planes, one axis of 6 pole and no horizontal plane of symmetry because center of symmetry is lacking. Common mineral is woodsite, greenockite and ginsite. And in 6 mm, in 622, it is a hollow axial class, no plane, no center. It is called as hexagonal trapezohedral class. Each face is a trapezoid-like face. Each face is a trapezium-like face. So there are this is a hollow axial class. It gives rise to enantiomorphic forms, provide enantiomorphic forms, left-handed, right-handed forms. Minerals are high quartz, calcite. These are the minerals, common minerals. And so centrally we have one axis of 6 pole symmetry, then we have 3 axis of 2 pole, 3 axis of 2 pole, 3 axial. These are the axial mirror, these are the axial axis representing 2 pole symmetry, and bisecting them we have another 3 axes. So these are the 6 axes of 2 pole symmetry and no plane, no center. In 6 by m, one axis of 6 fold, and perpendicular to it there is plane of symmetry. So horizontal plane of symmetry is there, and we have the one axis of 6 fold, and we have 6 upper faces, and we have 6 down faces. So we have 6 upper faces, we have 6 upper faces, 6 down faces, they are mirror image of each other. So in this manner we are having horizontal plane of symmetry, axis of 6 fold symmetry, and these are the faces. These are the upper faces, solid dots, down faces, open dots, they representing 12 faces, 6 upper faces and 6 down faces. Minerals are apatite. Common mineral is apatite, 6 by m. 6 by m is the class which represents hexagonal dipyramidal class. Simply this one, this will be hexagonal pyramid. But if you have lower form, then it will be dipyramid. So that has been hexagonal. Therefore, the form is called hexagonal dipyramidal class, because there are upper 6 faces which form a pyramid and lower faces which form another pyramid. That's why it is called as hexagonal dipyramidal class. And in case of 6 bar, it is equivalent to 3 by m. 6 bar is equivalent to 3 by m. So trigonal 3 faces, then we have 3 faces. This is trigonal dipyramidal class. Trigonal dipyramidal class. 6 bar is equivalent to, so we have horizontal plane of symmetry, that's why it is solid, because 6 bar is equal to 3 by m. So one axis of 3 fold. This rotor inverse 6 bar rotor inversion axis is, this is the rotor inversion axis, C axis, and 3 mirror planes. Sorry, one mirror plane. This is one mirror plane, horizontal mirror plane, which is solid, and no other symmetry is there. So we have the 3 upper faces and 3 down faces which are mirror image of each other. So we have 3 faces and we have their mirror images. So this is about the 6 bar. Then minerals are rare. In 6 we have, it is simply a pyramid, 6 faced pyramid, that's why it is called hexagonal pyramidal class. If in the bottom there would have been faces, then it would have been hexagonal dipyramid, as we find in case of 6 by m. So 6 means it is only a pyramidal class, hexagonal pyramidal class. There are 6 faces, these are the 6 faces, this is the axis of 6 fold symmetry, and there is no other symmetry element. Common mineral is nepheline. Then in case of 3 bar 2 by m, it is the normal class of trigonal division, and it is called hexagonal scalenohedral class, which is equivalent to 3 bar m, or it is a short form of 3 bar 2 by m. So one axis of 3 fold rotor inversion, or we can say one axis of 3 fold symmetry is there, center of symmetry is there, and 3 axis of, this is 3 axis of 2 fold, and this is 3 mirror planes, and 3 bar means 3 axis plus I. So center of symmetry is there, and one axis of 3 fold symmetry is there. So we have one axis of 3 fold, this is one axis of 3 fold, or we can say it is the, so this is one axis of 3 fold. We have the second 2, that represent axis. So we have 3, these are the 3 axes of, sorry, dotted, these are the 3 axes, these are the 3 axes. So axis of twofold, this refers to 3 axes of two-fold symmetry parallel to the crystallography axis, and perpendicular to them we have the 3 mirror planes. So we have this is the mirror plane perpendicular to this axis, this to this axis, this is the mirror plane perpendicular, and to this axis this is the plane perpendicular. So these are the 3 mirror planes, 3 axes of twofold, 1 axis of threefold, and there is no horizontal plane of symmetry. This by M refers to the vertical plane of symmetry. It is not horizontal plane of symmetry. So there is no center of symmetry. So this line is dotted. This is the common form. Minerals are calcite, corundum, hematite, brucite, arsenic, millerite, antimony, bismuth. These are the minerals which crystallize in this system. Now let us discuss 3M. It is trigonal pyramidal class. So this is 1 axis of threefold, C axis, and these are the 3 mirror planes along the axis. So sorry, these are the 3 axes vertical, and these are perpendicular to the A1, A2, A3 axis. So these are the axes, and perpendicular to these are the mirror planes, 3 mirror planes, and it is found in case of tourmaline, alunite. These are the minerals which show 3M means trigonal pyramid is there, and trigonal pyramid is there. Again, this axis of threefold contains another 3 axis contain mirror plane. So naturally, for each face there will be, each face will be divided into 2. So there will be 6 faces. There will be 6 faces. That's why it is ditrigonal, or it is said to be trigonal pyramidal class. It is trigonal pyramidal class 3M. Or it can be called as trigonal pyramidal class, or sorry, this will be ditrigonal pyramidal class. 3M will be ditrigonal pyramidal class, because there are 6 faces. There are 6 faces. So here there are 6 faces in 3M. There are 6 faces. So we can say it is ditrigonal pyramidal class. If it would have been 3 faces, then simply trigonal pyramidal class. As 3M, if it is 3, it is trigonal pyramidal class. If it is 3M, it is ditrigonal pyramidal class. So we have 1 axis of threefold, 3 mirror planes. These mirror planes perpendicular to the axis, and so we have the 6 solid dots, 2 around each axis of each plane of symmetry. So that has been shown here. So this is ditrigonal pyramidal class. In case of 3, 2, it is trigonal trapezoidal class. Each face is a trapezium, trapezoid like face. each face is a trapezium. So here one axis of 3 4, 3 axis of 2 4. 3 are the axis parallel to axis, 3 axis of 2 4, and 1 axis of 3 4. So this is 1 axis of 3 4, and these are the 3 axes. 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 So we have one open dot, one solid dot, one solid, one open, one solid, one open. Like this we have 6 faces. We have 3 upper faces, 3 down faces, alternating each other. That has been shown here. In case of trigonal trapezoidal class, no center of symmetry, only axial class, we can get the enantiomorphic forms here, right hand and left handed forms, because it is a hollow axial class. Low quartz, temperature quartz, cinnabar, berlinite, these are the common crystals, common minerals which crystallize with this class. Then 3 bar, it is rhombohedral class equivalent to 3 plus I. It is a rhombohedron. It has 6 faces, 6 rhombohedral faces, 3 plus I, 1 axis of 3 4, 1 axis of 3 4. Then we have the center of symmetry, and there is no other symmetry elements. So this is dotted. This is dotted. We have 6 faces on the top and 6 faces on the bottom, and they alternate each. These are the 6 upper faces. These are the 6 down faces. So this is the rhombohedral class. 3 bar, 3 axis of rotoinversion axis, or we can say this is axis of 3 4 symmetry plus inversion with the center, or it possesses 3 plus axis of 3 4 symmetry plus center of symmetry. Minerals are ilmenite, willemite, dolomite. These are the minerals which show this type of structure. Then we have the trigonal pyramidal class. 3 means only 3 faces. This is one face, this is another face, this is another face. So it is a trigonal pyramidal class, 1 axis of 3 4 symmetry. No other symmetry element is present. So 3 faces. This is dotted. No horizontal plane of symmetry is there. Gratonite example. So these are the 12 crystal system, 12 classes of hexagonal system. These 3 axis of 3 4 symmetry with a pyramid. So it is trigonal pyramidal class, and it is a open form because the bottom is open. The 3 sides, this bottom side is open. That's why it is a open form. And here 3 bar, it is 3 plus I. So no horizontal plane symmetry. So this is dotted. There are 6 upper faces solid, 6 bottom faces open. Rhombohedral class. 3 2, it is trapezoidal class, trigonal trapezoidal class, trapezium like faces, and 1 axis of 3 4, 3 axis of 2 4, 3 axis of 2 4 means it is these are the axes of symmetry. These are the axes of symmetry parallel to axis 2 4 symmetry. Then 3M, it is ditrigonal pyramidal class, 1 axis of 3 4, this is 1 axis of 3 4, 1 axis of 3 4, and 3 mirror planes perpendicular to the axis. This is the axis. So this is mirror plane perpendicular to it. This is the axis. This plane is perpendicular to it. This is the axis. This is perpendicular to. So three mirror planes perpendicular to the three crystallography axis. In 3 bar 2m, it is the normal class of trigonal division. It is hexagonal scalenohedral class, and we have 3 bar. This is 3 bar total inversion axis plus 3 axis of 2 fold. These are the 3 axes. These are the 3 axes parallel to which we have the 2-fold symmetry, and 3 mirror planes which are perpendicular to the axis. This is mirror plane, this is another mirror plane, this is another mirror plane. They are perpendicular to the axis. In 6, it has only 6 faces on the top. It is hexagonal pyramidal class. So these 6 have been shown, no horizontal plane of symmetry, that's why it is dotted. 6 bar, it is 3 by m. Horizontal plane of symmetry is there, so that's why it is solid. And 3 faces on the top, 3 faces on the bottom. That's why it should be because 3 faces they occur one below the other, that's why it will be 3 by m. So trigonal dipyramidal class. Then 6 by m, 6 faces on the top, 6 faces on the bottom, and we have this type of faces. We have a 6 by m, 6 on the top, 6 on the bottom, they are mirror image of each other, that's why we have 6 by m like this, one axis of 6 fold, one axis of 6 fold, horizontal plane of symmetry is there, that's why this is solid. 6 to 2, it is trapezoidal class. We have one axis of 6 fold, this is one axis of 6 fold, 3 axial, 2 fold, 3 axial, this is 3 axial. Then we have the diagonal. So these are the dotted lines because they only represent axis of symmetry, no plane of symmetry. Plane of symmetry is represented by solid lines. So these are all dotted lines because it is lacking plane of symmetry. So this is all about the hexagonal system, 12 classes, and in my next class I will discuss about the classes of cubic system. Thank you all giving a patient hearing to my talk.